we're trying to solve here? We're trying to solve this optimization process here, which is minimization of a loss function L with respect to theta. So in general, theta is going to be n-dimensional vector. And the question, how do we solve this? So we're going to stick with a method based on iterative method. So I will talk another method here that can solve this problem in one step. And just bear with me, I will go to that. For now, we're going to start with something called an iterative method here. So in this iterative method here, we start by randomly initialize your vector theta here. Start with random initialization. So again, remember that this is going to be n-dimensional vector. So if I do random initialization, I will need to generate n random numbers, and that will be assigned to the values of theta. So next step, I'm going to run multiple iterations. At iterations here, I will update parameter theta. And when I update the parameter theta here, I will calculate two things here. One is, what's the direction I will try to update the theta here? So that is called a delta theta. So delta theta is say which direction I should change the theta within a small step of that. I need to determine that through some methodology. The next parameter is this so-called a step size, alpha. So alpha is a scalar. Just keep in mind here is a number. And typically alpha, for example, and typically alpha could be small, alpha equal to 0.01 here. That's very common choice of the step size. Delta theta, on the other hand, is a vector in general, and the same dimension as the dimensions of the parameter theta. And that has to be determined at each step of iteration. And a different algorithm would give you different choice of the delta theta, okay? And alpha in general is called a step size. Or sometimes it's called a learning rate. So it depends on different contexts of that. So in the optimization community, people tend to call alpha step size, but in the machine learning community, we call it learning rate. They means the same thing. So now the key step within this iterative method here is determining which direction should I update the parameter theta. And then there's one method here called a gradient descent methodology, which calculates delta theta to be the negative of the gradient of the loss function with respect to theta. And what is gradient? Gradient is simply the partial derivative of the loss with respect to each individual component of that. So for instance, this is partial L over partial theta 1. If you carry out this calculation, because if you look at the functional form of the theta here, in the end, L here is going to be a function theta. And I can use a calculus to calculate what is the partial L, partial derivative of L with respect to each individual component here. And that is the first component of that. And then calculate partial L over partial theta 2, that would be second derivative, and so on. If I will be able to calculate all of them here, this guy's here, overall is called a gradient of this loss function with respect to parameter. Because whenever I need to calculate this quantity here, I need to evaluate this gradient at a particular value. And that is evaluated at this particular current choice of theta here. So as a result, this gradient you can see will be different depending on where you are right now. Because of a different theta, the gradient will be different. And that's exactly the reason we're utilizing this gradient information to update my theta here. And then use the opposite direction. And the reason I'm using the opposite direction because gradient overall is pointing to the increasing directions of the loss function. And then in this context here, because we are trying to minimize the loss function here, so that's the reason we'll put a negative sign in front of that so that where I update the delta theta, the loss function will decrease. Right? So that's the gradient update step. So let me just give you an example here and then to illustrate what does it mean, and then I give you some